So here's an interesting problem. We have a function, or a function divided into three parts. The first part is f of x equal 11 from x is less than equal to negative 2, which is basically a straight line. We have the second part, f of x equal ax plus b, from x greater than negative 2, x less than 3. And then the third part, which is basically another straight line, horizontal straight line, f of x equal to negative 9, where x is greater than equal to 3. And the question is, find a and b of this straight line here. So what I first thought of doing was like, well, okay, I'll draw a line, a graph here. And it's not going to be in proportion, but I'm going to mark off negative 2, and then 3, and then just to mark it, I'm going to say 11 up here, and then about negative 9 down here. So if f of x equals 11, where x is less than or equal to negative 2, that means it's 11 from here all the way horizontally forever. And then if we take this third part, f of x equal negative 9, where x is greater than or equal to 3. So down here, from this point all the way forever. So then you would assume, if this is a function continuous, then this line here will go from here down to here. And then this line will never quite touch negative 2, or I'm sorry, never quite touch 11, and never quite touch negative 9, but we'll come very close. So then the question is, find a and b. Well, here's the points. Negative 2, 11. Negative 2, 11. And then 3, negative 9. So the first thing I did, I didn't look at the answer. I did the brute force algebraic way. So the equation of a line in algebra is y equals mx plus b. In this case, y equals ax plus b. And then the slope is rise over run, which is change in y over change in x. So in this case, it is 11 minus negative 9 over change in x is negative 2 minus 3. And that equals 11 minus negative 9, which is 11 plus 9. Negative 2 minus 3 is negative 5. This equals 20 over negative 5, which is negative 4. And that equals a, which is your slope. So then you can use either of these 2 points to plug it back in. So I'm going to use the first one. So y equals a, which is negative 4, times negative 2 plus b equals 11. So then negative 8 plus b equals 11. And then I add 8 on both sides, and I will get b equals 3. So try it with this point too, just to double check, and you get negative 4 times 3 plus b equals negative 9. You get negative 12 plus b equals negative 9. I'm going to add 12 on both sides, and I get b equals 3. So I get 3. So b equals 3. So my equation is y equals negative 4x plus 3. So that's my line. Now that's the algebraic way, and that's cool, but this is about limits and continuity, so they really didn't want you to approach it that way. They wanted you to find limits as you approach each of these points with this function. So what is ax plus b? So all I'm going to do is do the first and the third one first. So the limit of f of x as x approaches negative 2 from the left, which is a little minus sign, of f of x equal 11. So then that will just be 11 because it's actually on the point. It gets closer and closer to negative 2. It's going to actually hit 11. And then the same thing with this one. As it gets closer and closer to 3, it will hit negative 9. So limit f of x equal negative 9 as x approaches 3 from the right side equals negative 9. So that takes care of those two. Now this one's tricky because it's two parts. So the limit of ax plus b, where x approaches negative 2 from the right, will be, now here's the thing, so as it approaches 2, it's going to be closer and closer to 1, 2 would be negative 1.99999. Never hits 2, never hits 11, but it gets very, very close. So the limit of this function as x approaches negative 2 will be almost essentially the same thing as you do here. So it equals a times negative 2 plus b equals 11. And then the same with the other part here, the 3. Limit ax plus b, where x approaches 3 from the left side, equals a times 3 plus b equals negative 9. So then, make sure I'm not running out of room here. Okay, so we have two equations. 2a plus b equals 11. 3a plus b equals negative 9. Now I'm just going to solve them. I'm going to subtract. So I'm going to do minus, minus, and plus. So then this will be negative 5a, 0, and 20. And then this will be negative 5a equals 20. And a equals negative 4, which is the same thing I got over here. Then I can do the same thing and plug these in here, and I will get b equals 3 for both of those. So this is just a more official way to do the limits. Also, I didn't point out that when I approach this side here, I'm going 2.99999 this way. So, and then I'm approaching 3. So that's that. So anyhow, that's the official solution here. Interesting way to look at this. Drawing the graph helps. You don't have to draw the graph. You can assume this is what it is, but it helps. And don't do the algebra. Just do that. Anyhow, that's it. And that was my email.